Assalamualaikum and very good day. So we had learned about the theory of DC motor on the previous lecture. So what we are going to do today is we are going to have a simulations on the DC motor by using the Proteus. So what is actually Proteus doing is basically the program that you are going to write is going to be implemented in Proteus, and also the same program can also be used on the hardware. But unfortunately at the moment, because it's in MCO things, you don't have the chances to do the hardware at the moment. So I hope that we are going to have a time soon later. So okay, let's start on the DC motor. Okay, before I want to proceed with the micro C programming, in the last lecture, for the simple DC motor activation, so it's very simple, right? So you have the DC motor. I think we can just do it from here. Find motor here. You can take the DC motor, which is a simple DC AC model, and also a battery. Right, so this is battery DC. Take DC voltage. Okay, so let's put up the motor here, and also put the battery here. So now, right now you have the battery, you have the motor. This is direct, right? So the maximum nominal voltage for the motor is 12 volts. So the battery is also 12 volts. Okay, you can change also the battery later. This is the one, right? Okay, let's try to connect this one. Okay, you're done. So let's run it. Look at the rotations of the motor. So it's a clockwise rotations once you put the 12 volt motor. So what happens if you change it? So delete this one, delete this one, and have this one here and also here. Okay, let's try again, run again. So you can see that now it's a counterclockwise. It's very simple. If you have a DC motor, you just can give a power supply to it and it will rotate. So this one you cannot control the speed because it's a battery, unless you want to try to change the value of this 12 volt. Look at the rotation wise. Let's try. I never tried it before, so let's try here, change it to 5 volt instead of 12. Let's try again. So you can see that yes, the rotations of the motor is much slower compared to 12 volt. So it seems that it's very clear that if you give a high voltage to the motor based on the requirement, the rotation will be at the full speed. So the slower of your the lower value of your battery, around 5 volt here, is going to slow down the speeds of the rotations. This is just like 5 volt here, for example. This is actually this is how it works. Works. So the concept is very simple. This is a direct one, not the PC, not the PIC. So here is the battery voltage, right? So this is the battery voltage. You can see. Okay, hold on. So this is a graph, right? So this is a voltage. You give 5 volt here all the time, so it means that rotation is good. This is, for example, 12 volt. The rotation is always like this, right? So this is a rotation. So if you give another value, which is maybe half of it, around 6 volt here, so the rotation will be a bit slower, half of the full speed. So this is a direct one. So that's why back to the thing that we learned before. We learned about the PWM, right? So you have the period here. For example, this is the period here. This is T. So the area under the graph, remember that you learned this one in Form 4, is going to be this is maybe 12 volt, right? So this is the period. So you can see how long it will be. So this is basically the value of the voltage given. So that's why it has continuous one, right? So every time period completed, so you have the total value of the voltage calculated. So just imagine that this is always there, always high, so means it's 100%. Same at this pattern. So in PIC it has the PWM, so that's why you are going to calculate the value under the graph here and get the value of the average voltage. So it's a very simple concept. Okay, alright, so we go back to Proteus. So this is very simple one, right? So right now we are going to do by using the PIC to control the motor. So we have the motor here, we have the battery here. So let's try, this is 12 volt, right? So I just want to make sure that this is 12 volt. So let's change it to 5 volt first, because I want to have a small version of a DC motor. So now you are going to your PIC16F877A, PIC16F877A. Okay, so this is your PIC, and you are going to use the driver, because without the driver you cannot drive the motor. That's why they call it the driver. The driver that we are going to use is the L293D. So this is the one. If you search in the internet, right, so this is going to be like this. Let me put it out this way. Okay, put this battery first. So you can see that you have the PIC, you have the driver, and you have the motor. Okay, what you want to understand about this driver? Okay, you have the first one, this first input here. Let me draw this one. You can use snipping tools to take only this one and paste it here. Okay, so this is your driver. So what is important about the driver? So this is a schematic. Let me try to get the components itself. Let me check. So this is the component. You can see that this is the component on the board. This is hardware. So this is the one that is simulation for this L293D. So you have to read all these pins. Which one is the pins? For example, this is pin 9. So you have to read which one is pin 9. So you start from here because of this this symbol 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 up to the data sheet. So over here, you look carefully. This driver can drive two motors at the same time. So this is the portion of it. This is the first one. This is the first one. And the other one is this one. So what does it mean here? In 1 and in 3 and in 4 is the couple. So in 1 and in 2, in 1 and in 2 is another couple. So remember that your motor have two input, right? So this is the couple. Then you have the in, then you must have the out. Okay, you must have this in, you must have this out, right? So what is this? Enable 1 pin. The EN pin is for the first motor, which is going to be connected at the CCP1 pins, or up to you, CCP2 doesn't matter, but you have to understand which one that you want to control. CCP pin 1, so I just want to use this one, it's much easier. So the next one will be the EN2 is going to be connected to the CCP2. So what is this function of this pin? Remember that if you go back to my last lecture, the CCP pins is the pins going to give the PWM signal. So that's why here you have to design the Proteus first. So here I want to design my motor driver will be connected to port B, because port C now I'm going to use as CCP pins 1 and 2 over here, right? So I'm going to use port B and port C for this particular driving the motor. So I can connect here, port B1 go here, and this one go to here, and then this is the one here, and the other points will be from here. Okay, so another pin must be connected at port RC. I want to put here port RC2 because this is CCP1, and this driver must be powered up also. Okay, so you are going to see this one. This is a VSS and this is VS. This is ground. So you just take the ground here, just connect the ground. This one should be okay. So what is VS and VSS? So VS is the power for 5 volt to power up the driver. For VSS means not voluntary separation scheme. This is word that I learned before. So the VSS is for the power supply or the battery if your motor is more than 5 volt. For example, your motor is 24 volt DC. So what you have to connect at this particular pin is a battery at 24 volt. So it can power up externally your motor here. If you do not put this 24 volt, then your motor cannot rotate because it requires up to 24, and this is giving only giving 5 volt only from your PIC. Okay, let's move on. So now I have disconnected. At the moment I'm using 5 volt. I think should be enough, so I don't want to put a battery over here. I will try later for the simulation if we have more than a 5 volt over here. Let's try later. So now we are going to write down the code. So if you go back to the micro C, remember this is a port B 0 and 1 we're going to use as an output, and this is also going to be a PWM. It's going to be an output also. So look carefully how I'm going to do this one. Okay, so you have your micro C, right? So this is void min. So I don't want to make a shortcut first because you guys still quite new on this. So the first one, you're going to declare port B as output. Trace B is equivalent to 0B 1 2 3 4 5 6 7 8, all of them. Okay, the current condition port B is equivalent to all 0. Okay. Then port C also you are going to declare it because the port C now is going to send out as the output. So trace C is equivalent to 0B. All I just want to put all as output. It's much easier for me. And the current state for the voltage all for port C is all 0B 0 0 0 0 0 0 0 0, and this is the last one. So it's done. And then you have the while one loop. Remember that while one loop, and then you have the bracket semicolon here. Then you're going to do whatever that you want to do inside here. Okay. So how to use the PWM, the library itself. So before that, you have to understand how the library and how to use it. So where you need to go is you need to go to the help first. Help, tolong help me. Okay, F1. So this is the what you call the like a data sheet here. This is the all the library that you have. So you can see there's a lots of library given in micro C. So you can just search for the index. First is PWM. So this is PWM all related. Just go to this library. Then you have this library. So what is under this library are these 4 commands. Okay, these 4 commands. Alright, so you have the PWMX initialize, you have the PWMX set duty, you have this PWMX start, and you have this PWMX stop. Okay, I'm going to stop for a while.